Okay, first thing I'm going to need you guys to do is you're going to have to break out your notes. Get some note paper. So if the sub or whoever's covering today, they need to pause this so you guys can get a piece of paper out and a pencil. You need to do that now because you're going to need to write this down before you do the ready, set, go today. So the first thing I'm going to do is I'm going to teach you how to find the rotational symmetries of any polygon. So here we have a pentagon because it has 5 sides. Pentagon. So if it has 5 sides, what you need to do is you need to divide this up into 1, 2, 3, 4, 5 different triangles. Okay? And I want you to write this down because if you write it down, you're more likely to remember how to do this for when it comes to quiz and test time. And when you do your RSG, it'll probably be natural for most of you to do this. All right, so here we go. How many degrees are in a circle? You guys know there's 360 degrees in a circle. So if there's 360 all the way around this thing, we take 360 and we divide it by 5 because there are 5 equal angles all the way around this pentagon on the inside. All these central angles. So that means one angle, if you take 360 and you divide it by 5, grab your calculajigs, you take 360 divided by 5, and you get 72 degrees. Now what does that mean? That means every single one of these little slivers is a 72 degree angle. So that means 72, 72, 72, 72, 72. You add up 5 72s, you get 360 degrees. So how many rotational symmetries does this have? Well, it has a total of 5. And so what are the rotational symmetries? Well, for your ready part of your ready, set, go, you're going to have to write down your rotational symmetries. So the first thing, if I take this pentagon and rotate it 72 degrees, it'll fall right onto itself. That's called rotational symmetry because it falls right onto itself again. It'll match up with itself. So it has, if I spin it 72 degrees, that's one rotational degree. Then add another 72 to that. So then it's 144 degrees. Add another 72 to that, and you'll get 216 degrees. Add another 72 to that, and you get 288 degrees. Add another 72 degrees to get that, and you'll get 360 degrees. These are the rotational symmetries of this pentagon. You're going to need that for the first part. I hope you wrote all that down because that's super important. 360 divided by 5 is 72. Another way to write this, you can write, instead of writing all 5 of these, you can say this has 72 times n degree rotational symmetries. You don't have to write all 5 of these, but I just want you guys to know that these are the actual rotational symmetries. But this also represents the number of symmetries it has. So 72 times n. So you could do 72 times 1, 72 times 2, 72 times 3, 72 times 4, 72 times 5 is 360.